day everyone. This video focuses on how calculus applies to real life, focusing on its two key points, which are the derivatives and integral. Derivatives measures the rate of change of quantity. For instance, velocity is the derivatives of distance with respect to time expressed as v of t and equals to s of t. Two scenarios will be shown to demonstrate each concept.
Trying to know how fast I'm moving at a specific moment while traveling to school.
Let's talk about the derivatives. So the distance traveled by the cyclist is given by the function s of t is equals to 5t squared plus 2t, where the s of t is the distance in meters and t is the time in seconds. To find the instantaneous velocity, we take the derivative of v of t is equals to derivative of s of t. Now, we derive the given function, which is v of t is equals to 5t squared plus 2t. So 2 times 5 is 10, then bring down t plus 2. After that, after we derive the given function, we will substitute. We will substitute t is equals to 3, which is the time in seconds. So, v of 3 is equals to 5 times 3. Now, we substitute with the given function t is equals to 3. Now, v of 3 is equals to 10 times 3 plus 2. Then v of 3 is equals to 30 plus 2, which we get is v of 3 is equals to 32. So the cyclist velocity at 3 seconds is 32 meters per second.
I'm jogging around the school campus and my speed changed to run. I would like to know the total distance I traveled after a few minutes.
As we saw from Drell's radio, it can be implied that this velocity is equal to the derived function, which is equal to 8t, wherein v is the velocity in meters and t is the time in minutes. To solve for the velocity in meters, we will be using a defined integral, wherein the first limit is 0. As it's the minutes started from 0 and the range run for 1 minute, so it will be 1. Then copy the right function, which is e, and then the derivative. And then we will use the power rule to solve for the integral, which is 8 times t raised to 1 plus 1 over 1 plus 1. Wherein 8 will be multiplied by t, or the time raised to 1, which is here an invisible 1, plus 1 over, copy the exponents, 1 plus 1. Now we will continue. So 8 times t raised to 1 plus 1 is equal to t squared over 2. Now we will multiply the 8 with t squared over 2, where it will be like a normal fraction. So 8 over 1 times t squared over 2 equal to, and of course just multiply like normal, 8 t squared over 3. Then you will need to simplify the fraction. So you can cancel this by dividing it by 2. Dividing it by 2 will turn into, will end in 4t squared over 1, or just 4t squared. This is our final solution. Final integral. Now, after solving for the final integral, we will now move on to step 2, applying the limits and substituting them. So, to apply the limits, we will basically just substitute for t with the limits here, 1 and 0. Then we will be subtracting them. So, if x or if t is equal to 0, then it will be 4t. Then it will be 4 0 squared equal to 4 0 times 0, which should be equal to 0. Next is if t is equal to 1, wherein 4 times the square of 1 will be 4 times 1, and with the final answer of 4. Now we will subtract these. We will subtract 4 with 0. So 4 minus 0 is equal to 4. So that means that dredge ran for 4 meters. Basically states that he ran with a velocity in meters of 4. That is all, and thank you for listening.
In conclusion, derivatives helps us determine the rate of change such as speed, while integrals helps us find the total accumulation of quantities such as distance traveled over time. That's all! Thank you for watching!